Alright, hello again, and this is the Chipmaster, and in today's video I have another repair of a PC, a Lenovo ideapad. Alright, I got it from another tech as is, right, and he said it's not turning on. Right, so it's very clean. See that the screws are already removed. Okay, so I'm going to plug in the power and see what is the current consumption and what's going on. Alright, so I plug in the power and I get nothing there. That's not taking any current. So let me remove the back cover. The screws are already removed, as I said before. So I'm just going to remove the back cover here. Get in the pry tool. Okay, so as you can see, the RAM is already out. The RAM is already out. The board is just laying there. No screws for the motherboard as well. Alright, so just move this out the way. Makes my life a little more easier to do the disassembly. Alright, so we're gonna check on the major coils. Let me just inspect the board as usual first for any liquid corrosion or any explosions. Just putting back the memory in the slot. Alright, so I'm looking around as you all can see, and I have not seen any visual damage. Alright, looking under this plastic area here, no issues, no problem there. Alright, so I'm continuing to check in the onboard RAM section here. No problems. No problems. Let's check the other side. Not seeing anything. No problems as well. Alright, checking just on this side. No problems as well. No problems whatsoever on this board. So I don't see any explosions, no liquid corrosion or anything like that on the board, yeah? It's all clean. So I'm gonna check the resistance. So first I'm gonna check 3 volts and 5 volts. Alright, so I have 402 there. Next coil, 437, that's good. Alright, checking the 19 volt rail, and I have a short. I have a short on the 19 volt rail here. This is the current sensing resistor I'm checking now. Let's check the battery charging section. All good. Okay, I'm now checking RAM supply. All good. Right. Bias chip pin number 8. Excellent. Right, this is a 11th gen CPU. As you can see, there are 2 RAM chips there. Alright, I'm checking the 1.8 volt. This is VCC in AUX. This voltage will supply an internal voltage because this 11th generation CPU supports the FIVR, which is the fully integrated voltage regulator module that's inside of the CPU. So on this newer CPU, you won't see any more coils on this side of the board, so there will be less coils, right? So there will be less coils. As you can see, I only have 2 coils here. Normally you have VCC SA here, right? VCC IO coil somewhere right here, and then the VCC core, and then the graphics, right? So we only have the VCC core. So the VCC SA, VCC IO, VCC ST are all now integrated inside of the CPU. So if I remove the CPU, you will see all those coils under the CPU, right? So this is indicating that it's a fully integrated voltage regulator, right? So this is 1.8 volts, right? So this voltage is a common point voltage for the CPU. So this voltage will now send to the internal PWM circuit inside of the CPU to produce the VCC ST, VCC IO, right? VCC SE, and all those internal system agent voltage for the Intel CPU only, right? And this is a common point voltage. Now, this voltage is voltage ID control, or VID, voltage identification, right? Which is going to commute with the internal PCH and the BIOS, right? So flashing random BIOS or incorrect BIOS into this board can cause the 1.8 volt to not be generated properly, right? Now, these small transistors, as a key support, are VCC, right? V1.05 volts. So let me check. And I get 123. Let's check the next one. That's ground. And I get 123. So VCC PR, VCC 1.05 volts. So I can call it VVCC VNN 1.05 volts. That is going to supply. This is an output voltage from the PCH. So after the PCH gets VCC in AUX, the internal PWM circuit will now generate VCC PRIM 1.05 volts and VCC 1.05 volts, right? Out, and FET, which is for the MOSFETs, which is these 2 MOSFETs that are going to switch to generate 1.05 volts, right? So this is also generated internally. These voltages are not really used externally, they're just there for reference to indicate that the PCH already accept that acknowledgement that it's already received the VCC AUX, which is 1.8 volts. Okay, and this is the CPU core coil, and it is going to generate the core supply for the CPU, right? And that's it. Sometimes it's used to generate the graphics card supply, because the VCC core supply is the CPU core supply is already generated inside of the CPU. So this is what makes it FIVR, fully integrated voltage regulator module CPU, which is starting from the 11th gen, which is the Tiger Lake, up to the Raptor Lake CPUs. All right, so I've checked all these coils. There's another coil here, and that's good. This is most likely for the a secondary supply, 0.9 volts, I believe. All right, so I'm going to check. So BIOS chip pin number 8 is okay. All right, the charging section is okay, right? 3 volts and 5 volt section is okay. VCC in AUX is okay. GFX core, or CPU GFX core, is okay. RAM supply section is okay, right? And this section is also okay, right? But we have a short on the 19 volt rail and the current sensing resistor here. As you can see, I'm getting 0, 0, 0. So that indicates that it's a short there, right? So most likely I will have to burn the board. Let me check secondary 3 and secondary 5 volt section. This is secondary 3, right? And this is secondary 5. Excellent, so there's no short there. Did I check this coil? Let me check. I get 222, and that's all good. And I already checked VCC AUX, and I get 304. So now I'm going to go and burn the board. So I'm going to solder a wire. Oh, I didn't turn on the iron. So I will burn the board now. Right, so I'm just adding some flux there at the adapter current sensing. Let's go under the microscope for this, shall we? As you can see, this is the current sensing resistor for the back adapter. Alright, so that's the current sensing resistor for the charger there. I'll fix this microscope. Alright, so here we have the current sensing resistor. I'm just adding some solder here. Alright, so I'm going to inject roughly about 5 volts here on this line, and then I'll go under the thermal camera. Alright, so we'll be on the thermal camera. Okay, so now I am going under the thermal camera. Here is it. And as you can see, I am now going to focus the lens. Alright, so the lens is focused. So I'm going to put my focus here. Normally, most times the short will normally take place on the CPU or the VCC NAOX line here. Right, so I'm going to just check here for heating. Right, so I'm going to go back to thermal vision and I'm going to hit seek, and then I'm going to adjust the slider here so I can capture the right amount of temperature range, and I'm going to give power. Right, so I'm giving power. As you can see, that section there is getting hot right there. This section is getting hot. I'm turning off the power. Let me see. So it seems like it's this cap here. Let me give power again. Let's take a look at the cursor here. That red cursor here, as you see, as I'm giving power now. As you can see, it's pointing right here, and it's 47, 49, 50 degrees. Right? As you can see, the temperature there is getting hot. Let me reseek. So that indicates most likely I have a shorted cap right here in it. So I'm just removing the board under the camera. Let me go back to the microscope. So I am having a short somewhere here. Could it be that this cap is cracked? Let me remove it. Alright, so I'm just adding some flux there. And I will just heat both sides together with my iron like this. And there we go. So let me see if I can inspect this cap, if it's cracked. First of all, let me check if the resistance is removed. Sorry, if the resistance is restored on this side. Let me see. Still have a short there. Still shorted. So it's not this capacitor, as you can see. I'm still having a short. Let me check the next side of the board. So the capacitor there is good. It's not shorted. Alright, let me check the next side of the board. Could it be this one? Because it's in this area that the camera has detected the short. Alright, sometimes it's not on the front, the side that you're actually seeing, it's on the next side of the board. So I'm just removing this, I'm just going to remove this other capacitor here. Alright, now it's removed. Alright, so it's removed. Alright, so I'm going to check. It's blurred. See if I can Focus, right? Alright, so let's go. We still have a short. Oh, it's cleared. Sorry, I was checking the wrong side. So this capacitor was cracked, as you can see right here. So I'm checking here, I'm now getting 480, and the common point voltage rail, which have 20 volts or 19 volts, is now restored. Right, so I'll just replace this capacitor. This is a 0603 20 volts, 25 volts capacitor with a 0 point, with a 1 point, with a 1 microfarad in capacitance. So I'm just going to remove. I'm just going to clean the board here with some 99.9. Let me just go back a little with the microscope. And I'll also remove this wire here. There we go. Alright, so I've removed my test short wire. And let me clean here with some 99.99. There we go. So I'm just going to get the capacitor. Alright, so now I have the capacitor here. Alright, so I'll just put one here, and I'll put back the one that I took off. That wasn't bad. And then do a hot check. Oops, two fell out. Oh, two of them. Alright, sorry. Alright, so I'll just add some flux here. Alright, so I won't use hot here, can just use the soldering iron and just touch the two sides together. Alright, there we go. I'll just add some solder to the tip of the iron and grab the both sides together. There we go. So I'll just use the tweezers there to just reinforce it there. There we go. Now I'll just add the other cap back to its original spot and then call it a day. Okay. Let's add some more flux here. And alright, I'm done there. Just clean it some 99.9. Alright, before, let me check the resistance again. Good, so I have 477, 478, 480, very good, so all is well. Oops. Okay, so I will now do some hot checking. normally these reverse bias MOSFETs or the adapter AC or cutoff MOSFET normally break as well. So I'm just checking it before, and it's good. As you can see, I'm getting 500 there. That's a diode, that's on the body diode that's inside of this MOSFET. And I'm checking the other one here. And it's good, 508 there. So the both of these adapter cutoff and reverse bias MOSFETs are okay. Alright, so now I'll apply power to the board. Now, as you can see, I have current there, 700 milliamp, 750 milliamp there. Alright, so I'm now going to check all the supplies. Alright, I get 20 volts there, 19.8. Alright, I get 5 volts, 3.3 volts. Excellent. 1.2 volts. 1.8, sorry. This is VCC PRM 1.8. This is 1.2 volts. Excellent. Now I have 1.8 volts. Excellent. 1.8 volts is there. 1.0 volts VCC PRIM VNN 1.05. 1.0. Okay, excellent. And the other 1.02 voltage. So these reference voltages are okay. So that indicates that all is well. Let me check if I get in PLT reset signal. Alright, let's go back under the microscope. Let's check for PLT reset on the Wi-Fi pin 52. Alright, so this is 2, 4. Alright, so that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52. Pin 52. Let's check if I get in 3.3 volts here. PLT reset signal. I apply power. Oops. Alright, so I'm applying power again. That's pin 52? Oh, that's the wrong pin. Hold it. Okay, just to confirm, PLT reset. So I'm gonna check on the schematic because it should be on pin 52. Alright, so just gonna confirm NM hyphen, right, so D461 one motherboard. And I'm just going to check the NMD461. Alright, oh, that's the board view. Sorry, this is a schematic. Alright, so this is the connection of a, confirm it, JW LAN 1. JWLAN1. It's found. Oh, sorry, I didn't put the L. Pause. Okay, so the schematic wasn't having the correct pages. Everything is disorganized. So I had to manually look for the reset for this wireless LAN connection. I was typing JWLAN1, but it's still not finding it, so I had to search for it manually. So we have here PRE reset. Oh my god, this doesn't support the reset signal. So this reset signal here, as I was checking pin 52, as you can see, we have a reset, right? PE reset 0, and that's coming to here. As you can see, it's active low, and this is WLAN reset. We have another reset signal here, right, which is not supported. So pin 52, this reset is the active valid low signal. As you can see, it's called WLAN reset. It's going to reset the LAN, right? So let me copy this signal because I wasn't getting it on pin 52. So let's see the whereabouts of this signal. Right, as you can see, it's coming from the CPU here. Let's go to the next page. Alright, that's not it. And it's coming to here as PLT reset and double LAN reset, PRES. Yes. And it should be coming to pin 50. Sus clock that is not used. Pin 52 is reset. Alright, so I'm going to try again because I know I was correct. Alright, so I'm going to give power again. Alright, so this is 22. Right, and that's 24, 26, 28, 30, 32, 34, 36, 38, 40, right, 42, 44, 46, 48, 50, 52. We have a resistor here, which is one side connected to ground, and this side is PLT reset. Is coming through this via here, coming to this resistor here on this side, and comes to pin 52. So I give power. Alright, I'm not getting it. Let's see if we're getting caps lock. Should be working. And the reset signal should be there at all times. Anyway, if it works, it's a work. Alright, so I'm plugging in the keyboard now. Zoom out some more. So 27 minutes gone. Alright, I'll give power. Alright, so the current is jumping 760, 708, 800 milliamp. And I'm not getting any caps lock. No caps lock, as you can see. And the current is, oh, there we go, we have caps lock. Shuts off. Alright, the CMOS, the RTC battery is removed here. So this is why it's turning on by itself. Alright, there we go. There's the caps lock. So it's all up and running. Let me check pin 52 again. Alright, so on this board, basically what I'm seeing, the reset signal will only be valid unless the Wi-Fi card is installed. The reset signal will be there. Well, the board is fully on. So I'm just going to put the board back into its case. Oh, so I'm going to pause. I'm going to solder a wire on this resistor on pin 52 and see if the PLT reset signal will come after installing the RAM. After installing the wireless adapter, sorry. Okay, so I've soldered the wire. So I give power. Let's see if we're going to get PLT reset. If it doesn't generate, that means PLT reset is active low on this board at all times. Or let me connect the power adapter, because I've plugged in the RTC battery. I'll just remove it. Alright, so as you can see on the meter there, we didn't get any voltage. So that indicates that the PLT reset signal is active low, even when I put back the wireless adapter. So PLT reset is active low. Yeah. So it's active low. So I will just remove it. So I'll just connect this I/O board here. Putting back the screw as though I saw it. Just gonna check if PLT reset is gonna be grounded also, if it's grounded internally by the PCH inside of the CPU. It's not grounded internally, it's just active low as I'm measuring. Right, it's not beeping, it's just active low. Alright, so I will connect back the RTC battery. Alright, so I'll now connect the back cover. Well, the screws are already removed. Alright, so let's see the actual display. Alright. Okay, it's taking a while. Oh, you see that? Go again. Screen was flickering. Oh, there we go. So as you can see, I have display there. Alright, so one more time. Alright, so that's a done job there. Alright, so that was pretty much simple. So I hope you enjoyed the video. I hope you learned something, and I hope you like and subscribe. Alright, so as I said before, I have a lot of work today. So in the next video, I will definitely maybe live stream, or I'll record another video repairing something for you. And I said again, I hope you enjoyed the video, and I'll see you in the next video on that day. All right, bye.